Okay, we're going to talk about how to solve quadratic equations by graphing. We've already learned how to solve by factoring. So if we look at this equation by factoring, if we solve it by factoring, it's equal to 0. So the next thing we have to do is factor this equation. We're going to use a zero product property to solve this. So if you're factoring this trinomial x squared minus 8x plus 15, we have to factor it using the x puzzle, and 15 on top and negative 8 on the bottom. Your signs have to be negative. Negative times a negative is a positive. So the factors are going to be a negative 3 and a negative 5. So our factors here are x minus 3, x minus 5 equals 0. The solutions are, if we have two things, so my two factors being multiplied to give you 0, one of them has to be 0. So if x is a positive 3, this factor would be 0, so that's going to be one solution, x equals a positive 3. The other solution is if x equals a positive 5, that would make the second factor 0, which no matter what the first factor ended up being, 0 times anything is always going to be 0. So those are our two solutions. To solve by graphing, you have to graph the related function. So instead of having an equation something equal to 0, we're going to have a function. So you can have, I'll write it down here, f of x equals, instead of 0 here, we have f of x. So we're going to graph that same one, x squared minus 8x plus 15. Okay, so we want to graph that in our calculator. For time being, we're going to skip this middle section of the notes, and we're going to plug this into our calculator on a graph page. So you can get your calculator, and the first thing we can do is open a new document, hit enter. Do you want to save the old document? No. When we plug in a new document, we can go down to add a graph, plug in a graph page. So the first thing I want to do is I want to plug in this x squared minus 8x plus 15. So if I'm going to plug in x squared, I go down, hit x squared plus 8x, minus 8x, minus 8x, and then plus 15. Okay. When you graph that, you get a parabola that looks like this. From here, we're going to plot it over on our grid over here. Some things you can use to plot this are, you could hit Control T. If you hit Control T, a table will pop up on the side of the screen, and that'll give you some points to plot. So here, if x is 1, according to our graph, the table, y is 8. If x is 2, y is 3. If x is 3, y is 0. If x is 4, y is negative 1. If x is 5, I think it says right there, y is 0. If x is 6, y is 3. X is 7, y is 8. So we're going to graph these points, 1, 8, 2, 3, 3, 0, over here to the right. So if we go to 1, 8, it's about there, 2, 3, 3, 0, 4, negative 1, see that line, 5, 0, 6, 3, 7, 8. Okay, you'll get something that looks like a parabola here. And that's how you graph your parabola. From here, the next question says, which 2 points out of these points that we graphed have x values that match the solutions we got in the original equation, where our solutions were x equals 3 and x equals 5. Well, when x is 3, y is 0, so that's one point that matched, 3, 0. The other point that matched was 5, 0. Okay, what do you notice about those 2 points? Well, their y values are both 0. Okay, where are both of these points located? If I ask you on the graph, where are they located on the graph? Well, here is 3, 0. here is 5, 0. Notice they're on the x-axis. Okay, both of those points are on the x-axis. Okay, whenever you're solving by graphing, plug in the related function into your graph. See, where does that parabola cross the x-axis? That's where your solutions are. Okay, here's your equation. Difference between equations and functions. Equations are equal to a number or value. Functions either equal to y or f of x. You could write f of x equals that x squared minus 8x plus 15. That's actually function notation, hence the f there. It's more accurate. Here, solutions and roots, those are the answers to the problem. When you're talking about a function, you talk about the zeros, where the zeros occur, or where x equals 3 and 5, that's where your y is 0. Or you can talk about the x-intercepts. Okay, so we're going to solve a couple. In here, we have a quadratic function, x squared plus x minus 2. When you graph this one, you plug it into your calculator. I'm going to show you a quicker way to just find the solutions, instead of trying to look at the table. So the next thing we can do, you can hit Control Document, and it'll add a page. We can add a graph page here. Once you add a graph page, I'm going to plug in that x squared plus x minus 2. So I got an x squared plus an x minus 2. When I graph that, there's my parabola. Basically what I want you guys to do on your graphs, I want you to plot the zeros, okay, where it crosses the x-axis, and then you can sketch your parabola. Those are the two important things we need right now. So I can clearly see that this one crosses at a +1 and at a -2. So here I'm going to plot a +1, 0, and a -2, 0. Okay, and then from my graph, it looks like it hits at 0, -2 here, so I could use that point. But basically, we can just sketch a parabola from our two x-intercepts. That's all I'm going to require of that. So here, where do the zeros occur? Well, the zeros occur when x is -2. That's when the y value is 0. And when x is a +1. Okay. Let's look at this one. If we were going to graph this the same way, okay, another way to get a graph page, you can hit Home, and then you can go down and add a graph page to your document. If we add a graph page, it'll start you off with a clear one again. From here, I'm going to plug in this 3x squared minus 7x plus 2. So a 3x squared minus 7x plus 2, I graph it. When I graph this one, I notice that this point looks like it intersects at 2, 0. This point does not have a very clear point that's in between 1 and 2. So in this case, what I could do here, I'm going to go ahead and plot that +2, 0. Okay, I want to figure out what's the other one. Okay, what is this other point here? One way we could do this is we can draw a line on the x-axis and ask the calculator to find where they intersect here. Okay, to draw a horizontal line, okay, the x-axis, all these y values are 0. So what we're going to do next is we're going to hit Tab. When you hit Tab, another drop-down answer, a drop-down function comes down here, and we're going to plug in a 0. This is when y equals 0. When you hit y equals 0, you get a line, a horizontal line at y equals 0. Okay, you have to have a line there so you can figure out where the pink line, in my case, and this black parabola intersect here. So to find the intersection, we're going to hit Menu. We're going to go to Analyze Graph, so go down to 6. From here, we're going to go down to 4 to find the intersection. The only tricky thing here is the intersection. You have to highlight where the intersection is. And what I mean by that, you click down to the left of the intersection, you click down to the right of the intersection. Oops. And it'll give you that point where they intersect. That point is a 0.33333, and instead of using decimals, we're going to use fractions. So does anybody know what 0.333 repeating forever is as a fraction? It's a 1/3, okay? So that means it crosses at 1/3, 0. So a third of the way between 0 and 1, okay? From there you can sketch your parabola. But those are where our zeros occur. Our zeros occur at x equals 1/3, and our zeros occur at x equals 2. Okay, let's do this one. On this one, this minus 25 has to be a plus 25, and someone made a mistake. So if you will put a minus or a plus 25 there, then we'll be on our way. So let's try this one. When you plug it into your graph page, you can go home, add a new graph page. We're going to plug in an x squared minus 10x plus 25. Okay. What do you notice about this graph? Okay, it only touches, the parabola only touches here. Okay, so in this case, there's only one solution. Okay, that's at a 1, 2, 3, 4, 5. Okay, that's at a positive 1, 2, 3, 4, 5. Okay, that's the only place where it touches the x-axis, as we can tell. So that's the only place that a 0 occurs, is where x equals a positive 5. That point right there is 5, 0. That's your x-intercept. That would be the solution to the related equation. Okay, I want to show you guys on your graph, when you're plotting your parabola, another way to graph it if you don't like looking at the table, you can hit menu, you can go down to view, and you can ask it to put lines on your graph, where you can hit grid, and then you can ask for either a line grid or a dot grid. Okay, if you do a line grid and you hit enter, it'll put lines in for you, so you can tell that the next point is up 1 over 1, up 1 over 1. So from here, my next points on my parabola would be here. Where's another one? So if I go from the vertex, if I go up 4 over 2, okay, that kind of actually. There we go. There's your other. That'll make your parabolas nicer if you do that. If you want to put a grid in there, cool. If not, no big deal. Okay, so here, where the 0 occurs, is x equals 5. Okay, let's do this last one. From here, we get y equals x squared plus 4. So I'm going to hit home. I'm going to add another graph page. I'm going to plug in an x squared plus 4. Okay, when I plug in an x squared plus 4, I get a parabola that's way up here. Okay, if I was going to graph that, it crosses the y-axis at 1, 2, 3, 4. So I could go up to 1, 2, 3, 4. 4. That was 5. Great. Somewhere count. Okay. And I could sketch a parabola like this. Okay. Does this parabola cross the x-axis? No, it does not cross the x-axis. So, is there a solution that we can see on this graph? No, there's no solution. If there's not a place where it crosses the x-axis, there is no 0. You can put none. Okay. If I asked for like the solution to that, what would be the solution? You would write, there's no zeros. There's not a place where zeros occur. What you would say is no real solution.